Okay, so in this section, we're going to be looking at verifying identities. Right? So what that is going to mean is essentially like little mini proofs where we apply formulas, identities to given equations, right? So the way we're going to approach this, so what we have in front of here are the fundamental identities, right? The first one, the cosine squared theta plus the sine squared of theta equal to 1, right? That comes, you see, from the unit circle, the Pythagorean identity, and the other two derived by dividing through by either cosine squared theta or sine squared theta, right? Now, the process of verifying an identity, right? So the problem would state here, verify an identity. Okay, and let's see either one of these. That's not the cosine squared theta, the other ones, right? The other one's got a little more to work with, right? The cosine squared theta plus sine squared theta equals 1 kind of just comes from our proof from the Pythagorean theorem itself. But the other ones, we can actually apply some of our previously discussed identities, right? So let's say we wanted to verify this identity. Now, this is a much different type of problem than, let's say, when in algebra we're asked to solve an equation or whatnot, right? So verifying identity means really the way you want to approach this is, even though we see an equal sign, we start off in verifying, asking ourselves, is this actually equal, right? So one of the common mistakes that I see here, right, when we're asked to verify identities is that students will move stuff from the left to the right, and that is going to be strictly prohibited when we're dealing with a verifying identity type problem. Okay, so when you come across a problem verifying identity, what really you want to do is, good help might be, is just draw kind of a line down the middle, or not necessarily the middle, down the equal sign there. And you want to avoid adding or subtracting something to both sides of the equation sign, right? What you want to do is you want to pick a side, right? The left or the right. And again, there's no necessarily right answer to it, right? We can work with either one, right? But there are some clues or some things to look out for that would make the verifying process much simpler or more straightforward. Right. The first thing to look for is look for the side that appears to be more complicated. Right. There's just more stuff to work with. Right. And here, looking at this, I can see, oh, well, the left side here with the 1 plus tangent squared theta, that seems to be a bit more complicated. Right. There's more to work with. Right. So once I identify that, I'm going to stick to this side. Right. So I'm going to stick to simply working on the left side. Right. And my goal is to manipulate this, applying identities, using some algebra where necessary, and then writing this, and then just working my way down till in the end, I'm left with the quantity secant squared. And that verifies it, right? Once you show that you did some manipulation on the left and you got the exact same thing that is on the right, you are not done, right? You have verified the identity. Right. So again, we'll start off simply working with 1 plus tangent squared. I'm not even going to bother with the secant squared. Right. I don't care what is there. Right. Now, so the next step is, well, what do I do? Right. One thing where you say, well, there's not much here to work with. The first step that you can always do is, well, let me apply my reciprocal identities here, or here my sine and cosine identities. Where how can I write tangent squared theta? I can write that as sine squared theta plus cosine squared theta. Okay, so that's one thing we can do. All right, and then so now from here you're like, all right, well, we did that, right? Now what? Now when I see this, I'm like, okay, well, there's 2 terms on the left, but I only have 1 term on the right. So maybe the next step would be to combine this fraction into 1. All right, so the way I'll do that is I'll have a common denominator, right? And my common denominator is going to be what? Cosine squared. So I want to write, all right, since there's really only 1 fraction. So I know the common denominator is going to be the the denominator of this particular fraction, which is in this case cosine squared. So now the next step is, how can I write 1 as a fraction with a denominator of cosine squared? Well, again, mathematicians' favorite trick, multiplication by 1. One of their favorite tricks. The other one is adding by 0. Okay. So multiplication by 1 is cosine squared theta over cosine squared theta. So where does that leave me? That leaves me at here. We have sine squared theta, right? So that's as is. And this 1 is now simply cosine squared theta over cosine squared theta. Okay. And again, at first, maybe you're asking yourself, this doesn't look like we're getting anywhere close to it being secant squared. Well, some patience, right? This is going to take some time, right? So we'll be patient here, and we'll go. The next step here is, now let me write this as one fraction, right? So here we have cosine squared theta, and then in the numerator, we'll have cosine squared theta plus sine squared theta. All right, great. After writing that, I'm very happy, right? As you can see here, right? What do we have here? Now is where we bring in, right, an identity that we can use, right? As we saw here at the top, cosine squared plus sine squared theta is equal to 1, right? That means those are interchangeable. Whenever I see cosine squared plus sine squared theta, automatically I can substitute. That is equal, right? It is an identity. We have shown that this is true. So I can just substitute here. In my next step, as I write this, we have 1, right? The numerator is equal to 1, and my denominator is cosine squared theta, right? Oh, now notice how it's becoming less kind of complicated, right? And now we're really at a place where we really like where this is going, right? Now I use my reciprocal identity, right? What is 1 over cosine? Well, that's secant. And 1 over cosine squared, that's secant squared theta. Oops. So now we're cooking here, right? Secant squared theta. And now as you notice what I did, right? Let me zoom out here. Right? What has just happened here, right? I started off with this verified identity. Remember, right? You don't need to write that question mark, but I think it's helpful to remind you that the question being posed is it true that these two quantities are equal, that those two expressions are equal, right? And again, notice, right, that line, nothing has crossed the line. I have not moved one thing to the other side. Okay, I strictly pick a side and work there. Okay, all right. So from here, notice that we now have proven that this is in fact a valid identity, which we knew already. We just verified it, right? Just kind of an exercise to see how this would work. Okay, so that is the process here that we're going to use when we're asked to verify an identity, right? We're being asked, are these two in fact equal? And how do we show that? Well, we do manipulation on one side of the equation, right, to make it look like the other side.